Let's see if this works. I'll wait for the chat to come in. Let's see. Bueller? Are we
We
here?
are on.
Are we here?
We are indeed.
Okay, now it's working. Hi.
Hi.
Let's try this again. Let me go over what I just said. Okay. Anyway, so welcome in. Good morning, evening, afternoon. Take two on this. We'll see if I remember what I just said. So today we have some interesting things to talk about because last week's event was kind of neat for a couple respects. The main part of it is the fact that you can see Aurora with a positive BZ, which confuses a lot of people, and rightfully so, because so many times we're told that you can't see it with positive BZ. But to some degree, it's kind of true because it's confined to the northern regions or southern regions. But it doesn't shut off Aurora. It just changes the way that it propagates through. So we'll talk about that. And, of course, we'll go over the event because it was pretty insulting for us in North America, to say the least. But some people got the good stuff out of it. Patrick did in Mackinac City did get some cool proton aurora that he saw from, because I mean it was kind of a higher energy event, like, you know, it hit G4, so you're gonna have some buildup of things going on. So even past the negative sector of BZ, you still got some kind of cool stuff that went on. So without further ado, I mean, I said hi to everybody and it wasn't even live, so maybe I gotta say it again. Sorry guys, but I appreciate you all being here. So anyway, we're gonna start with Helio Viewer because this shows the 3 different filament eruptions, because there were 3. It wasn't completely obvious at first. If you look at 211, this is why it's important to look at the different wavelengths, because in 211 you could see it, and I don't think it was super obvious in the other ones, which is why some people missed it. So I will start there. Let's do, we're gonna do, I think this is screen 1. Okay, so we're gonna do that. Okay, can you see this? Am I doing this correctly? I think it's up, so holler if it's not. But this is I'm not used to, you know, driving this all the time, so you know, with the double screens. So anyway, Helio Viewer, we're gonna play this a few times and you'll be able to see where all of this happened, and then I'll go through it one by one, but I'll let it play through a couple times before I stop it. So it was pretty cool, to say the least. All right, so the very first one is in this south.
Oh, you might want to check the screen sharing.
Oh geez. Okay, let me just drag it over here. I think it's there. It's funny because my computer has it as this is screen 1, and it even shows it, and then when I share screen 1, it doesn't show it.
Oh, well, try it again.
So, okay, now we're on screen 1 because hopefully I can see it now. Okay. This is amateur hour. Oh my god. Sorry. It's Easter. It's a holiday. Forgive me. Anyway, okay. So, I'll play it again. And you'll see them. It's pretty cool looking. The main ones are obviously there. And then I'll stop it and go through it. And so you can see the first one very slightly in the southeast quadrant over here. That's that first one. And then it goes into the big second one here. That's almost up and down, straight up and down. And then it goes into this really interesting one, this third one. And watch how it reveals the coronal hole that's underneath it. So this was the really interesting eruption, because it kind of, as Tanya said earlier, sort of lifted up the skirt. And it's like, oh look, there's a coronal hole. So this coronal hole ended up deflecting that CME a bit. So even though it had kind of like a southern propagation, kind of pushed it up a little bit. So it was definitely, but the whole thing, the whole event is really cool. So there you go. So there were three CMEs on this. So that being said, now let me stop this screen share and go back to here, because I think we can go to the slide deck now. If you want to do that, I'll have you bring it up, and then I'll just talk over top of it, so I don't mess up the screens again.
Well, let's do that. We seem to be more unplugged than usual today.
Yeah, I don't know why.
But that's okay. So let me share it. I got this. So that is the right screen.
Yes, we're good.
Yay! Well, we'll have to monitor the chat to make sure it's actually good, because we had surprises today.
Yes, we did.
But let's find out.
Yeah.
All right. So, going into what happened in solar wind, Maribeth, you want to take this one over?
So now that we're up here, so this is nicely labeled, and even with the coronagraphs, you can see through the solar wind the 2 days where everything happened. You have the sheath first and foremost, followed by CME1, CME2, and CME3, and they're boxed in. And what's cool what Tanya did here is she actually showed where in the coronagraph the signatures were. We like to call them thing 1, thing 2, and thing 3 because it's kind of funny too. But as you can see, CME2 was the one that brought us most of the negative BZ, which was our daytime, unfortunately. But yeah, that's kind of the breakdown of, we ended up getting all three of them, because there were some speculation that the first one was not even going to hit at all because it was pretty far off the southeast. So the fact that we did actually see all three of them was kind of cool to see. But it's definitely was not a clean event. So take that for what it's worth. I don't even want to add to it. I think that's pretty straightforward.
All right. So we did end up seeing a fair amount of CME interactions actually in this passage of the 3-train CME. This is a perfect example why it shouldn't be really called cannibal CME. It sounds really scary and really inaccurate, because we don't really see that much of the true cannibalism where CMEs cancel each other out. So there is probably some interaction, but most of it isn't. It's just not there. So we could see some CME interactions in transition, where slower CME, which actually was the first CME that erupted, it was pretty slow. So it was accelerated, and it was brought here along with the rest of the pack. You could see deflection and rotation, and actually that coronal hole with the third CME probably deflected it a little bit. You can see compression where CME is more compact, and that increases the magnetic strength of the CME. You also lose to some degree the magnetic structure in the process, because you just have a lot of deformation. Change in expansion too, so CME that is traveling behind another CME may be expanding at a different rate, so may not necessarily lose a whole lot of its magnetic punch, so to speak. You can see some evolution as CMEs are traveling. So reconnection is really something that is that single case of CME cannibalism, where CMEs of opposite polarities start to interact and they sort of erode each other. There is evidence that it's happening, but it probably doesn't happen that often, because you really need to have a perfect case for it, where CMEs are launched one after another and they're really of opposite polarity. And you do see magnetic structure changes, obviously, and there was actually a prime example of that happening too, because, can I go back? Maybe not. We are having technical difficulties.
I did.
As usual. Oh, yeah, I don't want to do that.
I wasn't expecting it to be this quick.
Yeah, I'm stuck. Oh, there we go. That's easy. Okay. Maybe not.
It's like, come on. There we go.
It's going in the opposite. So, there is really no clear flux rope for either 3 of those CME. So not even one of them had nice, clean flux rope because of either there was a CME chasing after it or there is a coronal hole fast wind that's chasing after that CME. So this is how things evolved. We had a very nice arrival just before 18 UTC. Magnetosphere was a little bit primed because we had some nice negative BZ feeding into the magnetosphere and magnetotail was loaded. So by the time the shock arrived, and you can see the nice spike over here, it basically kicked the entire system into Substorm. There was some negative BZ through the sheath part of it, and you could see where it was because it resulted in very nice storming for Europe. And then we moved into North American night.
This is where we got our title from, because you can look at this chart and you can tell exactly where the daytime was for us.
Yeah. So it was still high BT, so there was some activity happening in the evening, but once it moved into the night, it was really not that hopeful for us. But then by the time of our morning, of course, BZ turned south. And it stayed south for probably solid 9 hours.
Yeah.
So it resulted in fairly decent substorms. And it moved all the way to G3 and even short brief episode of G4.
Yep.
But then it was time for North American night.
There
and
it
we
is.
got nothing. We still had some substorming again, and this was the time when people actually saw a very nice proton aurora, both isolated patches and the arc, so that was really cool. Otherwise, we're talking about really high latitude substorm, and that's about it. So we didn't get much out of it. Even when our night was clear, we still didn't get much out of it. Not fun. I want a refund. This is what's just not fair. 3 CMEs and we get nothing? How does that even happen?
Yeah, it was entertaining to see. I was laughing all day long at work because I'm like, I can't believe this is happening. I can't believe it. It's just like so much activity. Like it was crazy too. It was right as the sun came up. It really was.
It was. It really was. All right. So one interesting thing, because BZ was nearly flat negative, we ended up with a little bit of a Sawtooth event. Usually those things are seen with CME and with storm time activity, although they can be seen at a quiet time. You just need consistent BZ north. Elevated BT usually is required, but again, not necessarily. Moderate to strong BZ and really steady conditions for several hours. You really need to move probably beyond 3 hours, because that tends to be the natural magnetosphere cycle. Substorming usually happens every 2.5 to 4 hours apart, and you could see it. This is what Europe looked like. Again, Europe and probably Russia. You see those periodic substorms. You get background steady convection because BZ is so steady, so you have consistent loading of magnetotail, but then you do get this periodic brief and very spectacular substorms. They're very brief, but they're fairly well timed. You almost can set your clock to it and say, well, okay, this substorm fired, BZ is still going, so until either it turns north suddenly or it sustains, you can sort of time where you're going to see Aurora. So moving to a different location or potentially staying put and just waiting for the next substorm to hit. You get diffuse Aurora in the background, and you get strong substorms. With strong substorms, because again, we're talking about storm time mostly, there is a good chance that you're going to see subauroral features. So you can see, I think Europe ended up seeing Ragda and proton. We saw proton,
Yeah.
so that's not as interesting. Ragda is actually type of proton aurora, just specific type of it. They also saw Star Arc, so Steve,
Yeah, I
all
think
those features you could potentially see with those substorms. They're short-lived and they're pretty violent. And then you go back to more diffuse aurora. Fun.
fun. Yeah, because
All right.
I think didn't Justin see that, or our friend Justin? He's a, but I forget if that
Yeah,
was,
he saw Steve, but actually he saw it with the substorm
yes,
on
it was
the
later.
night when it was later. It was
Yeah,
when BZ was not really in our favor.
right.
But he ended up seeing very nice Steve.
Yeah,
Very cool.
agreed.
All right.
Okay, what do we got next? Oh,
We got this.
so
This
yeah,
really strange substorm, or kind of breakthrough substorm and Aurora that happened with negative BZ.
yep,
Well, positive BZ actually.
yeah, positive BC. So the point of showing this slide is to clear up some of the talk and confusion about how Aurora doesn't happen with a positive BZ, but it does because you still have reconnection. It just happens in a different segment on the magnetosphere. So, or I should say, along the bubble, the neutral line, which is this little. I'm using my mouse. Like, can you see it? I guess maybe you can. I don't know, but around the bubble.
Nope.
Okay. So anyway, so you can see the difference here. Southern or negative BZ reconnection on the day side, reconnection magnetotail. It's a very efficient energy transfer. This is why this is what's preferred. So you get your isolated substorms, geomagnetic storms, diffuse or SMC auroras at times too. But if you look on the other side, on the northward IMF, you see the areas with the N neutral line. That's areas of reconnection. So it's still happening, but because it is much less efficient energy transfer, it takes a long time for that to build up, but it will eventually. And then you get to see these little substorms that happen throughout the night that people did see. So it's just one of those kind of things. It really has trouble, expanding the aurora oval. So this is one of those things that's more of the closer or the more north you are, or in the case of our southern hemisphere friends, the more south you are, which I don't think they can get that much further south because I think it's all water. The better off you are because you get closer to the oval and then you can see this. And being in the Great Lakes region, we're actually we're in a good spot. Like, several people got to see Aurora this night. If you looked at the Isle Royal Aurora cam, it was pretty decent. It was half decent, even with all this going on. And that's just, it's location. It really is. So yeah, Aurora still does happen, which is why you can't totally discount it, but it really depends on where you're at. Like, I was in Utah, so I wasn't even going to bother. It's way too far south. So, but northern Minnesota, yeah, you could definitely keep a lookout for substorming activity with this. So is that clear enough, or do you want to add to it? Make it more complex?
Maybe make it a little bit more complex
Do
and sort of not necessarily more complex, but more what to look for. So when you have easy north, so it's all positive, it really depends on how much of the total BT is sort of eaten up by that positive BZ.
Oh, yeah, that's right. Yeah.
So the greater the difference in absolute number of between BT and BZ, the more energy is being transferred. So if you have, for example, BT that's 15 and BZ 10, not going to get much. But if you have BZ that's closer to 0, even though it's positive, you're still going to have some energy transferred. Obviously, that's more of a continuum. So when BZ is going south, that's easy case. But it starts to be a little bit more nuanced when you have positive BZ. It's like, well, how positive is positive? How high is that positive? So yeah, looking for, and some of the apps do display it better. And my favorite is Glendale. It kind of shows just how low BZ can be. BZ cannot be lower than the total BT, so you cannot have a negative, like you cannot have BZ of minus 15 when your BT is 10.
Right.
It's just impossible. There's not enough IMF to feed into it. But BT of 10 and BZ of, let's say, 3, we're talking some business potentially for Aurora. There's going to be some energy transferred into Magnetosphere that's going to be enough to at least feed the diffuse Aurora and for some substorming. So it does matter how positive BZ gets. It's not all lost. All hope is lost when it's positive. Just positive doesn't tell you much.
Yes.
But just how positive is going to be enough to see Aurora at your location? Well, that's a big question.
Yeah.
It gets complicated.
But anyway, that's the gist is, so you can get it with a positive BZ. So there it is. But that's the illustration right there on how it happens.
Yep.
But yeah, to her point, so if you have an IMF of 15 and you have a positive BZ of 15, then probably not great.
Nope. Everything just moves north or closer to the poles, the south or the southern hemisphere, and it forms really strange aurora. But that's probably for a different conversation because I don't think anybody will really see it unless you're very, very close to the pole. So
Right.
Antarctica, yes. Minnesota, not likely. New Zealand, definitely not.
Yep. Okay. So there you go.
All right. So I think we're done with this topic, so we can move on.
Move on to our...
And
Oh yeah, substorm triggers.
we can talk about what to look for when you're trying to decide if it's gonna substorm soon.
Yes. So it's nicely labeled here. Shocks always drive substorming, especially when you have bits of negative BZ pushed in there too, like what we did. So that's an obvious one. But one that might not be so obvious is these beat drops in BT. That can trigger substorm activity too. And then, of course, the BZ flipping can do it as well. It does take some time for these things to propagate through. But when you look at the solar wind data, you can look for these little features, like, okay, something might be happening or will happen. And what is it, like 2 hours, give or take?
Yeah, it's about 2 hours, so it's roughly 2 hours. From BT drop, it acts very similar to BZ flip. You just get a significant reduction in just how much energy is being fed into the magnetosphere, so it doesn't have to maintain the same configuration. It's just gonna kind of shed something, sort of like I don't know, shedding for the season.
Yeah.
You don't need all that fur. You're just gonna drop it all at once, and then yeah, you're dealing with a substorm then. And for BZ flip, it's the same thing. So it's the propagation time, and usually that's basically just how long it will take from L1 to the to magnetopause. So it's not quite to Earth, but you can use that distance. And again, quite a few apps actually will propagate solar wind from L1 to Earth. So they will tell you how long it will take for the solar wind to travel, and that's part of it. For BZ flip and BZ drop, that's pretty easy. It actually takes another 6 to 8 minutes, sometimes a little bit longer, for the magnetosphere to realize that, oh yeah, something needs to be reconfigured. But usually it fires up pretty quickly. It takes longer for the BZ southward turning to feed the magnetosphere, particularly when you're starting with very, very cold magnetosphere and nothing is happening. It's reconfigured to the basically shape where you have fairly relaxed magnetotail. So you need to first of all get the solar wind to Earth, and that's the travel time, the propagation time, and that's based on speed. And then you have to load the magnetotail, and it takes about an hour or so. So that's the duration of the Dungy cycle. We kind of talked about the Dungy cycle and reconnection, opening and traveling magnetic field lines, loading of the tail. So think about it as it takes about an hour to stretch the slingshot so it can fire a substorm. So it takes you, it takes about an hour to travel to the store, so to speak, to buy a slingshot, and then it takes about an hour to actually stretch it and then let it loose. Yeah.
just like that.
All right. Okay.
Yeah, I think we're on current events now, if I remember correctly.
I think we are.
There we are.
And
So,
That's still fairly sizable.
yeah, it's not quite as big as it was last cycle, but it's still sizable, and it's a positive polarity hole. So we have that seasonality effect. The Russell McFerrin effect. However, it's gonna as these months roll on, that's gonna become less and less of a thing. Swipsy did put a G2 watch in effect for this. Actually, I think it's been updated for Tuesday and Wednesday now. And again, like we were talking about earlier, sure, this might have more. I mean, it's a coronal hole, so the BZ will oscillate here and there, but it was mostly a positive hole last time in a northward BZ, but it didn't shut everything out. So think about the stuff we just talked about, and this still has potential to be something, at least for areas that are in good location, I guess I'm trying to say. I think I had current solar wind too that we could go over.
I think I'm gonna stop sharing because we can go to current solar wind.
Yeah, so let's do that because I know I brought it up. So let's try. let's see if I can do this.
If you can find it, I can probably just share. We can go over it.
Let's see.
I think I might have it.
Share.
So give me one. Oh, go ahead.
Let me see if I can get it. Let's see. Is that showing
That's
Helio viewer, right?
Yeah, the next step. So real-time solar wind.
Okay.
You have it right after that flight deck.
There it is.
Yay! That's
all right. So let's make this bigger so we can see it. So this is what's going on now. As you can see, I think I put 3 days in here because we had a sector boundary crossing right here.
Yeah, you can actually uncheck the BX. It's pretty clear to see. Yeah. Hey, there we go.
So right here, we went from the negative sector to the positive sector. So that's happening. But what's interesting is we appear to have there's something happening, but we're not entirely clear what it is. It's one of those things we'll have to wait with time and see, because we have some elevated density here, elevated IMF. I mean, look at this. It's pretty good. But so we're gonna have to wait and see, because we think it's a little too early for that coronal hole, the big one anyway. So this is what's going on right now. It's not BZ wise. It's mostly you're getting a lot of this oscillation. So I don't know, what that's gonna end up transferring over, but that's what's going on now. And maybe in 24 hours we'll have a better handle on what this is. In terms of solar synoptic map, this is what we're looking at. I like these because it's like super clear. So we have our big coronal hole. We got this little island of it. But this is what we're anticipating is this here coming in. And it should be Tuesday, Wednesday, I think, with the timing. Because we did, in talking about like things that happened over the weekend, there was this little tiny guy. Little tiny coronal hole that may have fed some of the activity, but, not really. It was very small, so hard to say. I shouldn't talk with my mouth full, but again, I'm not like I'm not a professional. So I can do what I want. So anyway, that's what's kind of going on with the solar wind right now. So we'll just kind of wait and see what this ends up being, if anything, and then wait for the coronal hole to show up. So anyway, that's my short and sweet on the solar wind. Do you have anything else to add?
Not really. I think at least for North America and upper Midwest, we got clouds. Yeah. So that's not even funny.
No, I think it's supposed to clear out somewhat Wednesday. If I looked at windy, once this low pressure system pulls through, I want to say it was either late Tuesday night into Wednesday. There was like some clearing showing, so there might be hope. Maybe. But then there's another system coming in.
Yay!
So it's short-lived, but...
Yeah. Seems like lately it's been either full moon, clouds, or BZ north.
Yeah.
And it's pretty much, that's what we got for space weather and weather in general.
Yeah, all the things you don't want. And not at the same time. They're all spread out. So So you just can't win, but maybe we'll get it.
I'll take BZ North clouds and full moon at the same time,
Yes.
no problem. But
Yeah,
when we
that.
have, oh my God.
All right, well, let's see if there's
All right.
any other questions in the chat, but I think we might have covered it. So anyway, yeah. Anyway, that's our broadcast for the week. Hopefully you guys got something out of that. I mean, we'll be back next week with something. We usually decide somewhere in early in the week or middle of the week what we're going to cover. Or maybe the sun will give us something to cover. I don't know, but we'll see. I don't think there's really anything interesting. Like, I was talking to Christian, and the hot longitudes seem to be not in our favor. It's on the limbs. So like we get these big eruptions, but they're on the extreme limbs, which does nothing for us, unfortunately. So
well, apparently it's a myth because hot longitudes really are more of the Carrington longitudes.
Yeah.
So they do rotate, and that's
Yeah.
where basically active regions tend to pop up.
Mm-hmm.
There are nests, so sometimes
Yeah, because they can
several
change.
regions will appear in this at the same longitude. Same goes for coronal holes. We are kind of almost locked for longitudes for coronal holes. That's how they're going to rotate. And again, because the full moon cycle is 28 days and the full sun rotation is 27 days,
Oh, yeah.
we're kind of stuck with coronal hole for full moon, at least for one polarity.
Yes.
That's going to be, that's going to be unfortunate. Good question in chat.
Yeah.
Could 2 or more CMEs in quick succession link up magnetically to make a bigger effective CME? The bigger, more effective CME that results from 2 CMEs is if they are compressing each other.
Mm-hmm.
So linking up magnetically it's not super efficient. Those are huge structures. So linking it up in one big CME, that's sort of one big blob of BZ, that's all negative. That's not usually how it works. Compression and being more geoeffective, so causing more storming because of that, is very possible.
Yeah.
We actually saw it with May 10th when we had several CMEs. They didn't link up magnetically, but they compressed each other because they were launched in very rapid succession. So they ended up being incredibly geoeffective, and I mean, that's our G5.
Yep.
Not because they're linking up magnetically, but because they kind of stacked up on each other. So it's called pancaking, if you want food analogy. But yeah, that's how you end up doing that. October 10th was actually a single event. It was one long CME. It was deflected a little bit by the coronal hole that was north of it. So it was just one CME that was very geoeffective. But I think it was actually an X flare.
Yeah.
So it's not
it was.
surprising because it was launched with a lot of power. But we had an incredible week in October when we had something coming almost every day. So I was exhausted that week, but it was so much fun.
Yeah, that was a pretty good week. Oh yeah.
Yep.
She said she's thinking of the whole weekend. Yeah, because there was multiple things.
Oh yeah, multiple things, but they were really more like isolated things instead of several CMEs all at once.
Yeah. And
but
I got it.
October 10th was beautiful.
It really was.
May 10 through 12 was incredible, but we just don't have any region that is capable of producing anything like that at this time.
At this current time.
Yeah. Hopefully we'll get a surprise, but again, we're on the descending phase of the solar cycle, so coronal holes rule the show. They can be very geoeffective, but again, that's not as intense as CMEs, of course.
Yeah. So, there we go. I thought they would have already... Yeah, it was... I mean, that October... That whole week in October was pretty good, that's for sure.
Yeah.
So, I lost a lot of sleep that week.
It was fun, though.
It was.
It was beautiful.
It was fun, and we actually had, like, clear skies, to go with it. So, it was pretty nice, to say the least. Well, anyway, thanks everybody for being here. I guess we'll let this go for now. And then, like as usual, if you have any questions, hit us up. Or if you have any ideas for what you want us to cover, also let us know. But for now, we'll let you have your holiday evening back for those that celebrate Easter. So, thanks again. And we'll catch you next week.